Hello, scholars. Welcome to lesson 3. We're starting off our chemistry unit. And today we're going to talk about changes. Type of changes, physical changes, and chemical changes. All right? So, what's the difference? A physical change occurs, all right, when some of the properties of a material change, but the substances within that material remain the same. So, over here, we got wood, right? Physical change would be chopping the wood, cutting the wood, okay? Reshaping that wood. It's still wood, okay? You still have the lignin and the cellulose and the other things that make wood, all right? On the other hand, oh, by the way, you can also melt things, you can freeze things, you can dissolve things. Those are all physical changes. The chemicals, the substances, the molecules are still there, and those individual molecules are unchanged. They're so small, they're unaffected by the physical change. They may change form, change shape, okay, but they are still the same molecules. On the other hand, this is the chemistry unit. We need to understand chemical changes, all right? So a chemical change is when a substance is going through a chemical reaction, all right? And so one substance reacts with another substance and forms new substances, all right? So in these chemical reactions, you're going to have atoms from one molecule get taken apart, rearranged, and they form new molecules. So just like we said in our earlier lessons, atoms are the smallest piece that retain their chemical properties. That's exactly what happens, all right? I can take a molecule and break it down into smaller pieces called atoms. I take those atoms, which are the building blocks, Legos, of molecules, and I can rearrange those atoms into new molecules, kind of like we did yesterday in class with water and sodium chloride, and then we made hydrochloric acid, HCl, and NaOH, sodium hydroxide. Cool, all right? So that would be a chemical change because I'm rearranging those atoms. When we do that, these things called chemical bonds, which keep atoms together, they get broken, all right? And then we can form new ones, all right? So, example of a chemical reaction is taking hydrogen gas, oxygen gas, and making H2O. Now, it's not a balanced equation. We'll learn what all that is and the specifics and rules later. For right now, we know that the hydrogen, which is in this molecule, and the oxygen, which is in this molecule, get broken up and rearranged into a different molecule, H2O. They're chemically bound together. It's a chemical change. Come back to our wood example over here. We have wood, and when we put it in a fire, okay, when we burn it, we're mixing the wood with the oxygen in the air. That's called a combustion reaction, right? We'll learn more about that later. But in a combustion reaction, I'm going to take some sort of organic molecule and I'm going to burn it using oxygen. Oxygen feeds a fire. And at the end, I have something that is new. Where's my mouse? I have ashes down here, and I have carbon dioxide, which is the smoke coming out of the fire. And then there's things in the smoke as well, but I'm making new chemicals, new molecules, rearranging those atoms to make something different. Okay. Next lesson, we'll talk about how to recognize chemical changes. But for right now, make sure you have taken these notes and you've read your pages in the book and answered your questions. All right, see you in class.